Hi everyone, this is my first time recording a fun YouTube video. It's something that I've been played with, and I want to share with people who want to learn with me, learn about Linux and something fun about just playing with code for fun. Um, I'm pretty sure this is not a new discovery because I'm 100% sure people have done this before, but it is something that I didn't learn in school, and I was reading Linux documentations and Stack Overflow posts, and it is sort of something that I discovered by myself, so I take some pride in it. And I've been searching on YouTube trying to find people who have done this or show this demo um, before I have, and I haven't seen any people making a small project or demo or doing anything like this. So it has some sense of uh, new information in it, and I think it'll be fun for me to share this short video and demo with everyone. And it's more like a learning opportunity for me, and I hope you enjoy this video. And also, this is my first time recording any tech-related video too, so this is going to be fun for myself too. All right, so let's get started. So um, the reason that I started to look into this was that in class when I study operating system, I always have the impression that when you run something in the command line, you run your executable, you run a Python interactive window, or you run your compile code, you have your own process, and the process is heavily guarded and protected by the operating system, meaning that no one else should be able to read your memory, um, no matter no matter what you are, right? So that has always been my impression until I start to look into it, and the the result quite was well, it was different than I thought. The result was basically if uh, you have elevated privilege, you are pseudo privileged, let's say, you can pretty much do anything, which makes sense, I guess. But you can even peek into like other processes' memory, and I just thought like originally, if you're not careful, you are not doing any um, thing that you try to mix up the heap or the stack, people may be able to read into your process memory. And like, what if you store a password? That's a security vulnerability, of course, but not so carefully engineered software definitely makes that mistake. So uh, let's let's uh, let's start to take a look at the documents that I looked at when I was looking into and studying this project. Excuse me. Right. So there is one very interesting folder in Linux that is called proc. Um, basically, this is my double SL window. So basically, if you go to the root directory, you will see there's a folder that's called uh, where is it? Proc. Yes. So there's a folder called proc, and it is a collection of all the processes. So if I list it, I see all the processes, and um, and if you look at the Linux documentation, it says proc is very special. It's very special in that it's a virtual file system, and um, and it doesn't really contain any real file, but the runtime system information, and it also tells you that for these numbers, those directories within proc, it is referring to the PID, the process ID. And you may also notice that for the processes, they are mostly owned. They're owned by root, of course, and you see that these these folders all have file size of 0, which we can see here, all zeros, um, which the documentation basically explain it as um, as it's like a pointer or like a, I think it says right here, something like this. You may wonder how you see the details of processes that has a file size of 0. It makes more sense if you think of it as a window into the kernel. The file doesn't actually contain any data. It just acts as a pointer to where the actual process information resides. So that's very interesting. It's like if you are sudo, you can read into all the processes memory and the running memory. And there are a couple of important subdirectory within the process, the proc PID directory, and those are, let's see, those are, so I will be using them in today's short demo. Those are maps and maps. So maps and maps, and it basically tells you what it does is that memory for the maps folder, memory maps to executable and binary files, and mem will be the memory held by the process. So basically, if we dig into this, we'll be able to read the process in memory. Okay, so that's enough of the background. Let me show you the demo that I have been playing with, and I think it's pretty fun. Maybe it's a little naive for the real expert of Linux users, but for me, it is definitely super new. So, so the first thing is we want to spin up just a regular Python 3 terminal. So, and we can define some variables just for us to pick into them. So we can say we have a string, we have a string, we have a local string, and we call that this is a password. Okay, right. So, and then what we can do in Python is we can actually ID it. So it will return supposedly the virtual address of this variable, my string, and we will later see this address is most commonly stored as hex. So why don't we just convert it now? So you'll have to do it later, right? So okay, so we have the hex address of this variable. Okay, let's keep the process running. So we don't want to shut it down, right? Because if we shut it down, then we won't be able to read from it. It will just be it's more like a dangling pointer, right? So we still want to read it, so we need to keep this process running. And in the meantime, we want to know which process this Python is running at. So we can do htop, right? That's very easy. And we see we have a couple of Pythons running, and we can figure out which one it is. I believe I didn't shut down this virtual machine Linux environment, so there were a couple of the other Python kernels Python processes have been running, but I believe this one should be the latest one, and so we will know for this process. This is process 158. Okay, let's see. Okay, so now we know that this process is running on process PID 158. Let's take a peek at what the process folder looks like. So we have process, and we see a folder that is named 158, right? So we definitely want to cd into it. And of course, you will need sudo privilege at this point to read into the process folder. But we are root, so we can do it. So let's see. Okay, so all the folders are here. We have from all the documentation from the Linux documentation page. We are interested in the man, and also maps. Those are the two that we care about the most. So the maps actually tells you that which virtual page, which I'm not completely sure if it's saying virtual page, but I guess it's saying that which virtual page contains which virtual memory. And since from the ID here, we already know the virtual memory, the first step would be we want to see which virtual page that this variable lives in. So why don't we just dump everything in maps? Let's see if that works. Okay, so that works. And it just gives us a lot of the data. And from here, we can see, and basically this is telling you which for each of these pages, what from which address to which address that is containing its data. So we want to locate where our virtual address belong in the larger frame, so we can later on look it up. So since we are in last, we can just search string 7f 3355 4. Let's see if that has any matches. Okay, so we have some matches. We see that for our virtual address is 7f335547 something, 7f335546 something, to 7f335556D. So for 6 to 46D. Okay, so it's not in this page because this one is still 556 and we want to 554 to 556. Okay, so it's in this page, right? It's actually in this page because it contains the memory from 7f33554, 6, which is smaller than 47, and it all the way goes to 556, which is larger than 554. So we have located our page. Okay, so that's very good. Let's see what else we can do. Okay, so now we know the page. My first attempt was to just do the same thing. We can dump the entire process memory. So if we just do mem, I was expecting this to be successful, but then it wouldn't allow me. Oh, sorry, that's not in the process. Yeah, CD 158. Okay, so if I just dump the entire mem, it won't allow me to read because, like I believe it is, I'm expecting you to specify which page to read, and you cannot just read everything. So this probably corresponds to the Linux documentation, but this is more like a pointer. So you want to tell like whatever application you want to read it to say how much I want to seek. So what I found that would work is you would use you can use XXD, and then you pass in the seek flag. So dash S will tell you how much to seek, and then you'll specify where you want to start when you seek it. So, and obviously we want to start to seek at the beginning of the page. So 7F 3355 46 B000, as we have seen here. And then we want to tell it how long you want to seek. So you are passing the flag -L, and you want to say that you want to seek for the size of, you want it to dump the size of this page. So basically the later address minus the first address, 3355 6 33556 D 0000 minus, oh, I forgot the hex. Let's see, 7F. So the same stuff. 7F 335546 D000. Hopefully I typed in everything correctly. Using the dollar sign will make bash do an inline computation, which is quite nice. And then you want to tell it to look for the file called memory, mem, and then you want to dump it to left. Oh, sweet. So you dump to left. Okay, so we have everything in XXD format, so the address and then all the raw bytes in hex. And if we look at the address we are looking at, the address we want to know would be 7F. So let's see what we got at 7F. Okay, so we don't. So this is 5, right? So this is 5. So 7X is very down there. Oh, no. This is 554. So the first couple letters are already lost, already not showing here. Let's just make it easy. Let's just search for the secret message we are looking for. We're looking for the message called "This is a password." If we look for it, it says pattern not found. Okay, so I messed up somewhere. Okay, they changed line. Well, anyway, so we found our secret message. It's called my string. It's being stored as a plain text in here. And if we compare the memory, I would expect it to be close or the same. So 554, 7, E, 4, 7, 8. Five five four 7E108. 554 7 8. Yeah. So as what we can see here is that the memory doesn't completely match. 7 8 7E 7B. Okay, so the start is 7B, so it should be pretty close. But basically we can see, and I would expect some padding since this is Python string. They are rich objects, of course, so there will probably be a lot of padding. But we can see the content of the string is being stored at a location close to the location that the process has given to me. So this is it, the end of the demo. We indeed can look for other processes memory when you are a privileged user, of course, and just by doing this, hey, this is like super fun for me to figure out along the way, and I hope you enjoyed the video. Thank you.